To understand the solution for climate change, we need to first understand what is the primary cause of greenhouse gas emissions. Energy consumption by far is the biggest source of human caused greenhouse gas emissions, responsible for a whopping 73% worldwide. So, what do we use for satisfying our energy requirements as of now? Well, we use coal and fossil fuels. So, the solution is to find an alternative to coal and fossil fuels, and the alternative is something called as thorium based molten salt reactors. 1 ton of thorium provides as much as energy as 3.5 million tons of coal or 200 tons of uranium. We're going to run out of uranium in the next 20 years and coal and fossil fuels in the next 40 years, whereas we have enough thorium for the next 900 years. Then your next question might be, what about solar and wind? Well, let's start with solar. Solar either produces too much energy, which our batteries do not have the capacity to store, or otherwise it produces too less energy because it's cloudy, snowy, raining, etc. Solar requires a lot of land space and is too expensive. Wind does not produce sufficient and consistent supply of energy and requires too much land space and is also very expensive. If we were to run the entire world with only solar and wind, 50% of Earth's surface needs to be covered with solar and wind, which is not practical. Wind turbines kill approximately 600,000 bats every single year, which can lead to the endangerment of bats, which is not good for our environment. Wind energy also leads to the endangerment of eagles. Thorium-based molten salt reactors that we use the process of nuclear fission to produce energy like uranium-based reactors do. Thorium-based molten salt reactors have an efficiency rate of 99.4%, whereas uranium-based reactors have only efficiency rate of 0.6 to 0.7%. Uranium can be turned into weapons, but thorium cannot. As uranium-based reactors are the closest thing that we have which is similar to thorium-based molten salt reactors, it would be fair enough to compare uranium-based reactors to wind and solar for the time being. Let's take these two countries, France and Germany. France gets 71% of its energy from nuclear, whereas Germany gets only 50% of its energy from renewables. A new study by the Organization of Economic Cooperation and Development, OECD, shows us how Germany between 2006 and 2017 increased the cost of electricity for households by 50%. French electricity costs are just 59% of Germany's electricity prices. French electricity should be far more carbon intensive than Germany, and yet opposite is the case. France produces only 1/10 the carbon pollution from electricity. France generates 2 times more electricity from clean energy sources than Germany. Now let's compare thorium, uranium, coal, fossil fuels, solar and wind. First, let's compare these energy sources in terms of how much energy they produce. Well, thorium, 1 ton of thorium will produce as much as energy as 200 tons of uranium or 3.5 million tons of coal and fossil fuels. So 5,000 tons of thorium is enough energy or enough thorium to produce energy for satisfying the entire world's energy requirements for an entire year. Okay, similarly, we would require 1 million ton of uranium, or we would require 17.5 billion tons of coal and fossil fuels. To put that into perspective, we would have to cover 50% of Earth's surface with solar and wind to get our 100% energy from solar and wind, which is of course not practical. Availability. Now, we have enough thorium for the next 900 years. We have enough uranium for the next 20 to 40 years. We've got enough coal and fossil fuels for the next 40 years. We have an unlimited supply of solar and wind, but the problem is it supplies inconsistent energy, which can be one of the problems with solar and wind. Thorium cannot be turned into weapons. Uranium can be turned into nuclear weapons. And of course, coal and fossil fuels, you can't turn them into nuclear weapons, neither can solar and wind. Now let's look at the environmental impact. Now, thorium produces 0.6% of the nuclear waste that uranium does. So uranium literally produces almost 99 times more nuclear waste than thorium does. And plus the nuclear waste produced by thorium, scientists are actually working on innovative solutions to further convert that into more clean energy. And at least the nuclear waste of thorium can be contained, whereas the emissions from natural gas, coal and fossil fuels cannot be contained. In fact, these emissions are 100 times more radioactive than the nuclear waste produced by thorium. And you have to realize that 73% of our greenhouse gases emissions are caused because of coal, fossil fuels and natural gas. And it leads to the death of almost 7.7 million people every single year. Whereas the main environmental problem with solar and wind is that first thing, we have to cover 50% of Earth's surface with solar and wind. Second thing is that nuclear energy will produce 50% lesser carbon emissions, or I would have to be more specific, it would produce 50% lesser lifetime carbon emissions compared to solar and wind, which is a drastic difference in the amount of carbon emissions that is being produced between these two sources. Let me repeat, nuclear produces 50% lesser lifetime carbon emissions compared to solar and wind. And now we have to account into other factors such as wind kills 600,000 bats every single year, which can lead not only to the endangerment and eventually the extinction of bats, which is not good for our environment. And there are a lot of reports that say that eagles are led to endangerment, and it's bad for, and it can lead to the extinction of eagles if we further go ahead and build more wind turbines, which is again not really good. And now the solar panels also produce a lot of waste. In fact, it is more expensive to recycle solar waste, and it's more cheaper to actually get fresh raw materials for making solar panels than actually recycling the solar waste that has been produced. And this solar waste that's been produced, for example, when a solar company goes bankrupt, all this waste material that they have that cannot be turned into solar panels goes to poor countries and eventually gets dumped. Whereas nuclear waste is actually in the form of rods, and we have a scientific methodology to contain them such that it doesn't have an adverse environmental impact. Now you might be like, what if Chernobyl happens again? Well, Chernobyl cannot happen again simply because our modern day nuclear reactors come with nuclear domes. One of the primary reasons why Chernobyl happened is because the nuclear reactor in Chernobyl did not have a nuclear dome. Why? Because it was cheaper to make nuclear reactors with a nuclear dome, and that was the main reason, one of the primary reasons why Chernobyl became the disaster that it is right now. What about Fukushima? Well, Fukushima cannot happen because thorium by itself is not fissile. By that I mean that thorium by itself cannot be converted into energy. Thorium needs to be converted into fissile material, like something like uranium, and only then it can be converted into energy. Thorium by itself is fertile. That's why thorium cannot be turned into weapons. So therefore, because of the fact that thorium by itself is fertile, it's extremely easy to deactivate a thorium based molten salt reactor compared to a uranium based light water reactor or a heavy water reactor. Therefore, Fukushima cannot happen with the thorium-based molten salt reactor because it's fertile, and it's extremely easy to deactivate a thorium-based molten salt reactor almost instantaneously simply because it is fertile. What if we crash a plane into a thorium-based molten salt reactor? Well, the plane would just disintegrate. Nothing would happen to the thorium-based molten salt reactor. You won't have a nuclear bomb exploding. Another really amazing thing about thorium is that India has 50% of the world's thorium reserves. USA has got 23% of world's thorium reserves. Australia has 15.6% of the world's thorium reserves, and Canada has 5% of the world's thorium reserves. India initially planned to invest 63 gigawatts by the year 2031 or 2032, but now what happens is, because of a slow economic development and the fact that nuclear gets a lot of push against it, people don't realize the potential for this amazing nuclear technology that we have, which is specifically thorium-based molten salt reactors. It dropped down from 63 gigawatts to 22.5 gigawatts, and that's extremely slow progress. Because if India has to become a superpower, we want rapid economic development. At the same time, we want to fight climate change and save our environment. We have to invest in thorium-based molten salt reactors. We need to get 50% of our energy from thorium-based molten salt reactors by 2060. And we have, let me repeat, we have 50% of the world's thorium reserves. The objective of this video was to let you know about the existence of this beautiful technology known as thorium-based molten salt reactors. I hope you enjoyed watching this video. Please do like, subscribe, and share this video with your friends. Thank you so much for watching, and remember, keep being awesome.